In this video, we will learn how to take our empirical formulas that we learned to calculate from the last video and turn it into a molecular formula. So a molecular formula is only for molecules. And molecular formulas tell us the exact number of each element in a molecule for molecular compounds. This is not applicable for ionic compounds because ionic compounds do not form molecules. So this is only for molecular compounds. So let's do an example problem. This will include a bit of review of getting the empirical formula and then how to get the molecular formula. So we learned in the last video that we can assume that we have 100 grams of our compound. Well, let me read the question first, I guess. It says, determine the molecular formula of nicotine, which has a molar mass of blank and 74% of carbon, 8.7% hydrogen, and the rest is nitrogen. Okay, so if I assume that I have 100 grams, then I can turn that into a gram and that into a gram. And then it doesn't actually give me a real percentage of nitrogen, but all percentages add up to 100. And so I can subtract from 100 in order to get the amount of nitrogen. So 100 minus 74.0 minus 8.7. And so that tells me that I have 17.3, and I'll just write grams of nitrogen. So my first task is to arrange these in the order that they will appear in my chemical formula. Carbon will appear first because it's the leftmost nonmetal here, and then hydrogen comes second, and then nitrogen will appear last. And so I will take my periodic table. Carbon is 12.011 grams per 1 mole. Hydrogen is 1.008 grams per 1 mole. So we're just converting each of these masses into moles because our subscripts relate counts of things, not masses. So 74.0 divided by 12.011. I'm skipping the times 1 because anything times 1 is just itself. So that is 6.1610 blah 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 moles of carbon, and then 8.7 divided by 1.008 is 8.63095 mole of hydrogen. And then nitrogen is gotta hit enter first, 17.3 divided by 14.007, and so that is 1.23509 moles of nitrogen. So I can write out my tentative chemical formula. C6.1610, hydrogen 8.63095, nitrogen 1.23509. This is really hideous And the smallest something can be is 1. This is a little bit more than 1, but I still want to make it a whole number. And so I'm still going to divide by that same smallest value across the board. That will turn my chemical formula into I still haven't learned how to save numbers on this particular calculator app. I'm really going to figure that out soon. Okay, so that's carbon 4.99988. Hydrogen, that's 8.63095 divided by 1.23509, and so that is 6.988, and then my nitrogen will just be 1. And so those are really close to whole numbers, and so I'm going to say that if I had used the full number instead of just what I had written out, it probably would have been closer to the full thing. But this is my empirical formula. Now I have to figure out what the molecular formula is. And so the molecular formula is always going to be some multiple of the empirical formula. The empirical formula is the lowest whole number ratio, and so perhaps the molecular formula is twice as much or 3 times as much as this. And so we need some basis of comparing what the molar mass of this is. Well, I guess we're going to be comparing the molar mass of this to the molar mass that we're given. And so we know that the molar mass of nicotine is equal to 162 grams per mole. And our molar mass of C5H7N is, let's calculate that, 12.011, that's the mass of carbon, times 5 plus 7 hydrogens, each hydrogen is 1.008, plus 1 nitrogen, 14.007. You can pull those from the periodic table. So that's 81.118 grams per mole. So let's see. If I divide the bigger number by the smaller number, it will probably give me what to multiply by. So 81.118. So that's about equal to 2. So that tells me I gotta erase something over here so that I have more room to write on the slide. Sorry. It's like being in class when the instructor runs out of whiteboard space. I ran out of whiteboard space. Gotta have room. Okay. So that tells me that my molecular formula is twice as much as whatever this empirical formula is. And so that tells me what to multiply by in order to get to my molecular formula. And so my molecular formula will have 10 hydrogens, 14 hydrogens, and 2 nitrogens. Yay! Okay. Here's a practice problem for you. In an earlier video, we calculated the empirical formula of beta-carotene to be C5H7. In this problem, we are given the empirical formula is C5H7, and we're given the molar mass. Go ahead and try to pause the video and figure out what the molecular formula of beta-carotene is. Unpause the video when you are ready to check your answers. Okay, let's work this out. And so we're going to compare the molar mass of beta-carotene, which is 536.8704 grams per mole. And we're going to compare that to the molar mass of the empirical formula. And so we got to calculate that. There are 5 carbons. Each carbon is 12.011 on average. And then we will add that to 7 hydrogens. And so that will be 67.111 grams per mole. And so we got to compare these. We'll divide. So that's 536.8704 divided by 67.111, and that tells us 7.99973, which is essentially equal to 8. So we need to multiply our C5H7 by 8 to get to our molecular formula. So we will have 8 times 5 is 40, and then 8 times 7 is 56. And so our molecular formula contains 40 carbons and 56 hydrogens. Those are some big subscripts, but it's real. Here's another practice problem for you. It reads, vitamin C has a molar mass of 176.12 grams per mole and is 40.917% carbon, 4.578% hydrogen, and 54.505% oxygen. What is the molecular formula of vitamin C? Go ahead and pause the video and work that out in your notebook, and play the video when you are ready to double check your work. All right, so we won't need the molar mass right away. What we need to figure out the empirical formula is the mass percent composition. And so we will write this out as 40.917 grams. I'll just change each of those percentage signs into grams. Grams of carbon. We'll have to get into moles. We will divide by the molar mass or multiply by the reciprocal of molar mass in order to cancel out our grams and get into moles. So notice the grams cancel out, and then I'll be left with moles of carbon. So that is 40.917 divided by 12.011. So that's 3.4066 moles of carbon. Then we have 4.578 grams of hydrogen. Convert that into moles using the molar mass of hydrogen from the periodic table. And so that is 4.578, not writing on the right line, 4.578 divided by 1.008 as 4.54167 moles of hydrogen. And lastly, we have oxygen. which is 54.505 grams of oxygen, divide by the molar mass of oxygen, 15.999 grams of oxygen. So that is 54.505 divided by 15.999. That's 3.406775 moles of oxygen. So I've got to divide by the smallest, and the smallest looks like it's the same for both carbon and oxygen. These look the same. So it's really a matter of hydrogen. So this 3.4066, hydrogen 4.541667, and then oxygen 3.406. I can't write really close to this divider here. And so divide all of them by the smallest, which for carbon and oxygen will just give us ones. And so we got to divide 4.541667 divided by my previous answer, and that is 1.333. That is about 1/3. So I got to multiply. So that's about 1/3. 1 1/3. So I got to multiply everything by 3 in order to turn that into a whole number. So that'll give me carbon 3, and that will give me 4 hydrogens. Okay, so all of that work was just to get me to the empirical formula. What I needed to find was the molecular formula. So I'm still not done with the problem. So that's the empirical formula. So now I need to compare the molar mass of vitamin C molar mass of vitamin C was 176.12 grams per mole, and the molar mass of my empirical formula, C3H4O3, is, let's find out, 12.011 times 3 plus 4 times 1.008 plus 3 times 15.999, 88.062 grams per mole. So 176.12 divided by 88.062 is about equal to 2. Gotta make more room. Gotta make more room. I wrote too big. It's not that I wrote too big. I just have a very limited amount of space on the slide. So this tells me I need to take my empirical formula and multiply by 2, and then I'll get my molecular formula as C6H8O6. So my molecular formula is C6H8O6. Okay. This is the last practice problem for this unit. module for the module. So go ahead and pause the video and try to work it out. It reads, the granulated sugar you use when baking is sucrose. Sucrose has a molar mass of 342.3 grams per mole. 1 tablespoon of sugar contains 6.4783 grams of oxygen, 5.3054 grams of carbon, and 0.8162 grams of hydrogen. What is the molecular formula? And the box got misaligned between my tablet and my computer. So we'll just cover this up for now. Cover that up. You gotta prove it. Okay. Let's do the math, shall we? Whew. Feel free to pause the video at any point if you want to catch up. Okay. So we have, I'm going to rearrange these in the order they would appear in a chemical formula. Carbon would appear first, hydrogen would appear second, and oxygen would appear third. So carbon is 5.3054 grams. Carbon is the most left of the nonmetals. Hydrogen is inserted like after carbon a lot of times. So 12.011 grams per 1 mole, and that is 5.3054 divided by 12.011, 0.4417 moles of carbon. Hydrogen is 0.8162 grams of hydrogen, and this is going to be 1.008 grams of hydrogen, and so that is 0.8162 divided 0.8162 divided by 1.008, 0.809722. And then oxygen is going to be 6.4783 grams of oxygen. And then divide by the molar mass of oxygen, 15.999 grams. And so we will need to do that. And so that is 6.4783 divided by 15.999. And so that is 0.404919 mole oxygen. And so it looks like hydrogen is the most here. Oxygen is the least. So everything's going to be divided by the oxygen mass, mole ratio. So we got to divide everything by oxygen. Oxygen will just be 1 by the time it's divided by itself. And so my 0.4417 divided by 0.404919 is carbon 1.0908, hydrogen is 0.809722 divided by 0.404195, 4919. 4919. And so that's about 2. And then my oxygen is 1. Now, this carbon one does look like it's really close to 1. So if you rounded it, then like I couldn't totally blame you. But we were given this hint right here. And it says that 1/11th is equal to 0.0909 repeating. And so this is 0.908. And so it's really close to 1/11th. And so following the hint, which I'm sure that they gave us for a reason, I gave you for a reason, we should multiply everything by 11. So I think I can get to my history here and pull up that last value. Where is it? The 1.09 number. I probably hit clear. 1.0908 times 11. It's about equal to 12. So C12 H22O11 is my empirical formula. Now I have to figure out what the molecular formula is. So let me make some room. To find out the molecular formula, we have to compare the molar masses. So let me just write, this is empirical formula. So now we have to compare the molar mass of sucrose which is 342.3 grams per mole, to the molar mass of this. So the molar mass of that is 12 times 12.011 plus 22 times 1.008 plus 11 times 15.999. And that works out to 342.297 grams per mole. So if we compare these, it works out to 1. And so that tells us that our empirical formula is our molecular formula. So our molecular formula is sucrose, and our empirical formula of sucrose is C12H22O11. If you have any additional questions about this section, do not hesitate to contact me. Love to see you in office hours, and we can work you through this. Cheers.